Hey everyone, welcome to the Containers Workshop. As people are getting settled here, just wanted to do a quick little announcement about the logistics. So you can see on the slide up here, we have indicating to complete the setup section of your document. So this includes downloading Docker, installing, pulling your IRIS images, things like that. So if you haven't done that, take the next few minutes and get started on that. Just a few housekeeping things. All of our InterSystems helpers are over in this corner of the room. They have the white lanyards, so feel free to raise your hand, and some are walking around as well. Feel free to raise your hand if you have questions or need any assistance. We do have some loaner laptops available as well on a limited basis, so if you have issues installing on your machine or you don't have your machine, visit the helper table over here and we can get you signed out with a machine. So we're going to get started at about 2:15, so leave a few minutes here to set up, and we'll kick off the first presentation and get into the exercises at 2:15, so we'll do that. In the meantime, just feel free to begin pulling those images if you haven't, and let us know if you have questions. Thanks. Hey everybody, I think we're going to get started here, and so just to give you a little background, as we do these presentations, like you can take a quick pause from working, or you can kind of keep going as we're presenting. It's okay. So my name's Derek Robinson, and this is the Containers Workshop at the 2023 Global Summit. So just to give a little introduction, what I'm going to do here is kind of give you an idea of what we're going to cover, what the exercise covers, and a little bit about the structure of the workshop that we're going to go over here. Obviously, we have from 2 to 6, and I'll give you an idea of kind of how things lay out during that time. Just one more quick thing. I know that some people are probably still downloading, but hopefully during this time, things will finish downloading. And again, reach out to the helpers if you're still having issues as we get started on the exercises. So topic-wise, here's a little bit of a rundown of what we're going to cover. We'll go over the introduction. Like I mentioned, I'll cover some of the workshop structure we're going to have. I'll do a brief presentation on what containers are, really basic for people that are not as familiar with Docker. Actually, before we start, a show of hands, how many people here have worked with Docker before? Okay, so a good number of you have some familiarity with Docker. A lot of the beginning of this workshop is Docker basics, and then you'll get into some of the IRIS-specific stuff in the second half. We'll work with InterSystems IRIS and containers, use durable sys, take a closer look at some build processes, build scripts, Docker files, Docker compose. And then exercise 7 is really your kind of putting it all together exercise where you'll take an application, containerize it, and do some things with it. So we'll have presenters that are introducing those each of the way before each of those chunks. So as I mentioned, I'm Derek Robinson. We'll also have Eric Hemdahl, Carrie Kirkham, and Bob Kashevsky. They're over here. They're going to be the other presenters throughout the workshop. And we have a whole bunch more of InterSystems staff here to help you. So feel free to just raise your hand if you have any issues at all. Somebody will come by to help. So the workshop structure, 4-hour duration from 2 to 6 p.m. You don't have to stay the whole time. If you finish the exercise and you're free to go get ready for the welcome reception, by all means do that. You can have further chats with us if you want. Helpers can assist with the setup. As we mentioned, the loaner laptops are still available, a few of them. Presentations at different breakpoints, and one of the important things here, which is obviously a bummer if you have to use the laptop, the loaner laptop because of the network, but these are really designed to be taken home. So even if you are using a loaner and you'd like to do this later, the GitHub repository there has the entire thing, slides, exercise, and all the resources that you need. So it's really designed for you to continue playing with containers afterwards as you get home. So here's the schedule. Hopefully it hasn't been shifted too far down from the network issues, but really, this first half hour was always designed as the setup in the intro. Then there'll be a block of time to work on exercises 1 to 3. And then we just wanted to kind of timestamp when we're planning to give the presentation so that, it's 4 hours. You might take a coffee break, take a little walk, if you don't have to sit here for the 4 hours straight. So this is kind of when we're planning to have the presentations, and we'll have it on the screen when the next one is coming. So like while you're working, you'll see when the next presentation is going to be happening. So Eric will present at 3, Carrie at 3:45, and Bob at 4:30. So a little bit of an introduction, and this might be redundant for many of you who have used Docker, but we do have some people that probably are net new. So what is a container? Containers generally are platform-independent units of software packaged with all of their code and dependencies in what's often lightweight and efficient and portable. As you might have noticed, these containers aren't the most lightweight. The images that you're downloading today are like 1.9 gigabytes, I think, but they're IRIS on a VM would be a lot bigger than that. So containers are runnable on any host system that runs a container engine. Eric's going to talk a little more about some of the details of Docker and kind of the files that help these containers run, but runnable on any system that has a container runtime engine, not as dependent on the host OS as you'll see with a lot of other applications. and portable and efficient. So one of the distinctions that you'll be doing throughout exercises 1 to 3 and beyond in this workshop is really the difference between container images and containers. As people get started with containers, that's a commonly confused thing, right? So for kind of an analogy, you can think of the container image as an installable software package. Now, they're not installed on your machine. It's not like, it doesn't mean that you're installing it, but if you're making it comparable to sort of more traditional software deployment, think of the image as the EXE or the installable software and the container itself as the running instance of that, right? So as we go through this exercise, you're going to make both container images and then you will run containers from those images and you'll kind of see the difference and where those fit into the equation. So as I mentioned, very efficient. One of the biggest use cases for containers in the DevOps realm is this kind of efficiency to go from development to testing to production, not having as many build dependencies, as many kind of code dependencies. Really, as your container moves to a new system, it can run on that clean environment with its dependencies in the same way that it would run on the other environments. So you don't have the build discrepancies you might get if you're building on one machine, testing on another. Containers are meant to work through this life cycle very cleanly and efficiently. And one of the important things about this as you start to build out DevOps teams is that it allows your developers to really focus on the code of your application and not have to be worried as much about the deployment and the DevOps part of it. So the delivery of the application is a lot cleaner and able to be focused on by the operations team rather than your developers having to worry about the delivery aspects while they're coding the application. So a little bit back to the build and run of kind of difference here with container images and containers. So with a container image, you'll be running the Docker build command. That's going to be in the exercise there. And that is creating that image that you will run future containers from. You'll use a Docker file, which Kerry will talk about more in his presentation, which really will define how that image gets built. And then for a running instance of a container, you'll use the Docker run command. So as you look at the commands as you're going through, if you're less familiar with it, anytime you're running a Docker build, you're creating an image. When you're running a Docker run, you're creating a container, an instance of that image. With that, that's the introduction. So you can now begin on exercises 1 through 3 if you haven't. You can ask for help, raise your hand. And the next presentation, as I mentioned, Eric, will be at 3 p.m. So if you finish exercise 3, you're welcome to keep going. If you prefer to get out of here before 6 o'clock, there's nothing stopping you from proceeding. But the things that are beginning in exercise 4, Eric will be presenting about at 3 o'clock. So any questions, just flag us down, and we hope you enjoy it. So, thank you. Hey everyone, quick announcement. 2 things. One, the hotel is trying to add more bandwidth for us, so we're working on that. And the second thing is, I forgot to mention this, but the repository has a text file and a Word file that match the PDF basically. So for copy pasting commands, if you are going to copy paste, we recommend you use the text file or the Word file and not the PDF. The PDF is very funky with copy pasting. So those are the 2 quick announcements. Hopefully better network performance soon. We'll find out if they can raise that bandwidth for us. But continue to just raise your hand and flag one of us down if you have issues. So, thanks.
So welcome back. So I'm going to talk about InterSystems IRIS in a container. Well, I want to talk about some differences between running IRIS in a container versus running it on a virtual machine, or running any applications in a container versus a regular machine, whether it's bare metal or VM. I want to talk about some important features we put into IRIS to make it easier to run in a container. Years ago, I remember hearing the old saw that you can't run a database in a container. Yes, you can, and we figured it out, and we'll talk about why. And then I want to take a look at a Docker run command that actually runs IRIS. And we'll talk about that in detail so you can see what goes into running IRIS in a container. Let's first talk about the difference between a container and a virtual machine. Right? It's a big area of confusion when you get started looking at Docker or just container technology in general. A container is just a process, or maybe a process tree. It's just a job running on a machine. Its files are ephemeral. Right? By default, there's no state in a container. And it's isolated from the rest of the system. right? Isolated in terms of access to storage, access to the network, and so forth. Conversely, a VM is just that, it's a machine. Right? So you may have a big hardware server, then you've got a hypervisor to manage a bunch of guest VMs, each one with its own operating system, with its own devices, with its own storage. So they're different. Virtual machines allow for density of machines on a given piece of hardware, a given server. Containers really give you density of applications. They're a lot more lightweight, and they're a lot more efficient. But that's not to say that one is bad, or one is good, or better than the other. The use cases are different. Let's say you need to do a lot of testing. So you need to have machines with a whole bunch of operating systems, maybe with different versions of operating systems, but you don't want to have racks and racks of equipment. VMs are good for that. But maybe your challenge is one, and maybe you've heard this at work, you know, gee, it worked on my machine, right? If that kind of system drift is your problem, it works in dev, but it doesn't work in live, or it works in dev, but it failed in test. That's where containers really shine, because the container image moves from environment to environment. So I mentioned that containers are isolated, and when I started thinking and working with containers, I thought, great, that's like my application is behind a firewall. But that's not right. When you put an application in a container, think of putting it in jail, right? Its file system is isolated. Its network access is pretty much non-existent unless you do something about it, right? When the container is deleted, its files go away. And as I mentioned before, so that means that by default, containers are stateless. That's one of the reasons why we start this training with BusyBox, because we don't have to worry about storage. It doesn't have any state. You can start and stop and delete containers to your heart's content, no big problem. Now think back to the initial exercise, right? You created the test.txt file. And then you started another BusyBox container and you went looking for the file and you couldn't find it. That's because you had a different container and they've got isolated storage, right? That's the kind of isolation that we're talking about when we're talking about containers. Well, if you think for a minute, this isn't going to work for IRIS. It's not going to work for any database, right? Because we can't just turn IRIS on and off. There's a shutdown sequence that has to go through. There's a startup sequence it has to go through. We need network access, right? A database isn't too helpful if you can't get data out of it, right? And of course, we need persistent data, right? That we're all about the data. So let's talk about how we do that. And I want to first talk about the orderly startup part. So when you run IRIS in a container, you don't start IRIS. What you actually start is a helper program that we created called IRIS main. And the job of IRIS main is to handle controlling IRIS. So IRIS main actually does the startup of the actual data platform itself. Well, this is all running on a host, so the container might get signaled to exit, like when you shut the computer down. So when that happens, IRIS main intercepts the signal and handles a clean shutdown of IRIS for you, right? And if you can take a look at the picture here, I actually went inside an IRIS container with a Docker exec command. And then I did the PS, the process status command, to show the process tree. So if you look at the top, the first job is called Tinny. And this is a component we add as an initializer. And one of the important things it does is it adopts any child processes that get created in the container so that when they exit, they don't become zombies and start eating up resources on the host. Tinny starts Iris main. So this is, again, this is the lead process for an Iris container, right? After that, you can see Iris main by itself, and you'll notice ISC agent. Anybody use mirroring? I don't see, oh, a couple of people, right? I always forget to start ISC agent when I want to set up a mirror, right? So as a convenience, we start ISC agent by default for you when you're running a container. If you're not going to use it, fine, it does no harm, but it's nice not to forget about it. Right, going a little bit farther, the next process, you can't really tell what it is, but it's the control daemon. And you can tell that by looking at the process IDs, PID column and the PPID column, the parent process ID, and you'll notice that it starts all the rest of the Iris daemons that we know and love. At least I hope we know and love them, right? Or else we wouldn't be here. So that's what it looks like inside a container with Iris. Now let's talk about persisting data, right? That's why we're here. So what we've added is the ability for Iris to recognize a special environment variable, ISC data directory, right? You set this directory to a value that points to a directory outside the container on the host. And that's what we call the durable sys directory. So that directory has to be outside the container. It won't do much good if it's inside the container. It's on the host. When Iris starts up for the first time in a container, it's going to copy the manager's directory to that durable sys directory. So those key files, the IRIS sys database, the journals, the messages.log, the CPF, the data that Iris needs to run is going to be stored outside the container. Now, if you start a container with a newer version of Iris and you point it at your durable sys directory, Iris is smart enough to notice that and do an upgrade in place. And as I recall, we have an exercise where you get to do that a little later on. Question?
Can the contents of that directory be distributed across multiple underlying devices for performance reasons?
As far as I know, yes.
Just thinking about you start wanting to spread out your things like the wigs and journals and such. Data.
What you can do there is you can specify multiple, they're called bind mounts or volume options, which I'm going to get to in a minute, right? These are all put, this directory takes care of the core data that Iris needs. Now, if you have other directories with data you need to make persistent, if you have other databases and they're in other directories, then you would add more of these, you would add more bind mounts, which I'm going to get to in a moment. All right, so we give you this script in one of the exercises. This is a Docker run command. We put it in a script just to make it easier to type. And I want to walk through each of these items and describe what they do, right? Because it's kind of important. Let's put it all together. Okay, so it's a Docker run command. The backslashes just are some syntax to say, let's continue one command on one line. The first options, -p or -- publish exposes network ports. Right, and the syntax is on the left of the colon, it's the host side, and on the right side, it's the container side. So this first one says, take port 52773 in the container for the private Apache web server and expose it on port 80. When I do that, if I'm outside the container, I can point a web browser at localhost and I can get to my private Apache web server and I can get to like the management portal, right? The second one, of course, is the super server port, and that's the standard port. So we're just going to expose that at 1972, right, by default. All right, now, if you're going to do this in the exercise, if you've got a version of IRIS that's running, then you may need to change some port numbers here. If you've got a web server that's running on your machine for some other software, you might have to change it from port 80. This is a bind mount, the volume option. And again, the syntax is a directory on the host on the left and a mount point inside the container on the right. So this says, go to my current working directory, find a subdirectory called durable, and mount it inside the container at /isc. This is a bind mount, right? We're going to use this for durable sys in the next step. If you have other directories that you need to mount into the container, you just add more of these directives, right? This is why I like to put Docker run commands in scripts, because they get long. Here's where we set the durable sys directory. With the env or environment option, this tells Docker, hey, set this environment variable in the container's environment. When it's there, IRIS knows to look for it, right? So this is saying, go to that mount point, /isc, and let's create a directory called iris.data.d, and we'll use that for durable sys. So all those files from the manager's directory, they're going to end up here. Right? And notice that the durable sys directory is underneath its mount point. I've had more than one WRC case when I was in support where a customer would make them the same. And that causes trouble, because if the directory is not empty when you start, and IRIS can't find a good installation there, then it won't start up. And that's annoying. Okay, we have a few more details. You may have seen these already in the earlier exercises, right? --rm says, when the container exits, delete it. That's not a problem if you've set up durable sys and any other bind mounts that you need, because that data is going to be preserved. But what this allows is that as you start and stop the container, as you reuse this run command, you're not going to gather up stopped containers that are going to end up consuming resources on your host. Detach simply means run it in the background. Right? When I'm trying to debug getting a container started, sometimes I'll leave this option out, because then I'll see the log of the startup, which is oftentimes helpful in debugging. But if I know my container is going to run, if I've got everything working right, generally you want to run it in the background. And then --name just says, give it a convenient name, so I don't have to keep remembering that long, nasty container ID. And finally, at the very end of the run command is the image that we want to run. And there's a lot of information here. So this tells me that containers.intersystems.com is the registry server where I should go to look for this container image. InterSystems is the repository on that registry. In this case, IRIS community is the name of the image that I want to run. All right, we're going to use the community edition in the exercise. And on the other side of the colon is the tag, which is used for versioning, right? So instead of saying version 1 or version 2 or latest, we use the build identifier that we would assign to an IRIS kit. So that's the whole Docker run. Those are the basic pieces you need to get IRIS running in a container. So next up, exercise 4, give it a try. Take a look at the run command that we've given you in the exercise. As always, ask for help. When you finish, we're planning a coffee break. And next up, we'll see you at 3:45. Yes?
So you talked about IRIS main, starting IRIS,
Yes.
stopping IRIS. Does that mean that that's the only way, once you started IRIS, if you want to stop it and start it, can you be inside the container and start and stop it?
Yes, you can. So when you ran the BusyBox exercise and you exited BusyBox, it was done. The container was finished, right? And if you had used the RM option, then the container would be deleted. You can certainly enter the container with a command like Docker exec. You can use a command like bash to get a shell inside the container, and from there, you certainly can do an IRIS stop or an IRIS start if you've stopped it before, right? Now this is the important part. In that case, IRIS, the data platform, will go down, but the container will still run because you haven't shut down IRIS main. And that's another important reason why we put that process in there. All right, so I mentioned on this slide that there are a bunch of options for IRIS main. And when you pull the slides out of the repository, that's actually a link to our documentation. There are options that you can pass to IRIS main to do things like start the container, but not start IRIS itself, or not run the ISC agent if you don't need it. There's an option to specify where to find the license key, because when you're running a full version of IRIS, you do need a license key. And there are many dozens of others, so you can tailor that kind of behavior.
So let's go through the next few slides and talk about a few other ideas around containers, and then we'll get to the next set of exercises. So we're going to delve into containers a little bit more. I mean, for me, certainly when I got to, started, pulling the images, running your first few containers, there still seemed to be a little bit like a black box. So you need to try to get used to that and figure out how to interact with them, how to see information about those containers, etc. So we're going to try and delve a little bit more into the actual containers and talk about them. First thing is just to reiterate and talk a little bit. This is a command you've run already. So this is a really useful command. The Docker exec command allows you to, as you've seen, do things inside, execute commands inside your container. So from your command, you can do things like copy files into your container. You can run a shell command, an interactive terminal, for example, within your container. So typically, you've seen this already in the exercises where you run Docker exec and your container ID, and then you can do things like list the files, etc. You can use it to start an interactive shell, for example, using Docker exec, specifying the IT form, so you can use it interactively. You can do things like like copy files in and have it run in a detached mode, so it happens in the background, for example. So it's just a really useful command for being able to do things inside your container, inside the container itself. The other thing is information within a container. How do you see what's going on inside your container? So one of the commands that's really useful in terms of doing that is the docker log command, or docker logs command. So when you think about a container, as we've said already, a container is a process, right? So that process can be interacted with. It has standard output information, so it writes information about the container to standard out and standard error. And these are typically then interacted with, so you can follow what information is being written, the messages. And that's what actually the docker log command does. It allows you to read and visualize and get the information streaming from standard out and standard error, for example, and see that and output it. You can follow that information if you wish to. If your information is running in a non-interactive way, which again would be typical for a database, of course, then that information can be written to log files. So in addition to the output, you can read it interactively through the standard outputs. You can look at the information which is written to a file. So we'll do this in an exercise. You may have done this already. It's at the end of exercise 4. Where we'll be looking at the container logs command. There's a lot of different options you can use with that command. For example, how much detail do you want to see in terms of the information that's been written to the log? Maybe you want to follow the information for a specific container, so you can use the follow flag and then specify the container ID that you're interested in following. And then things like, do you just want to see the last few lines of the log, of the output? There could be a lot of information in these log files, so you can do things like specify time spans and, from a period of time to since certain activities, etc. So they're just different flags that you can use to configure the information that you want to see and the information that you're interested in. Like I mentioned, as well as the information that you can follow interactively, there's also a standard output that Docker uses to write the information to log files, okay? And by default, it does that in JSON format. There's a JSON file driver. You can use different drivers. The default setting is for the JSON driver. And it actually writes the logs to a directory. So where does it write them? Well, the root directory for Docker is this var.lib or /lib/docker directory and within that, there's a containers folder, and in there you can see, if you list, it'll show all the IDs for running containers and even for containers that have exited. And then you can use that and go in there and actually look and view the log files themselves. This is just a kind of it's not an exercise that we're going to do, but this is just to show you how you would go about doing that. I just ran this quickly on my own machine where I listed I listed the processes running, the container processes, and then you'll recognize the command that I used. It's actually, we did this with BusyBox. I used the Alpine, which is similar. It's like a Linux toolbox, if you will, and it allows you to open up a shell. And what I did was I simply just switched into, or listed the folders in that containers file, in the containers directory, excuse me, and you can see the list there in purple of all the IDs of the containers either running or that were ran. I just used then the cat command to output the file, just write the file to the terminal. Okay. We've also talked about building your own containers, or building containers, or building your own images. So far, we've basically pulled images and we've run them. Okay, but really what you want to start doing now is looking to create and build your own images. So we're going to do an exercise as well where we look at the build process, and for that we're going to use a Docker file. We're going to create a Docker file and specify the commands in that Docker file to build our own image. Very, very simply, a Docker file is just a text file. There's no extension to it, so we'll create that. And it contains the script and the list of functions that the commands you want to execute in order to build your own image. And there's various Docker file commands you can use. From is the first command in a Docker file. There's one from command in a Docker file, which allows you to pull your starting image or your base image for what you're going to build in terms of your own image that you want to create. So the process is, we create a Docker file, we run the Docker build command. I think it was Derek who mentioned the Docker build command and the Docker run command at the outset. We'll run the build command. That will actually then create our own new Docker image, and then you can execute the run command on that to then run that image, or run your container, run the container, which is the running version of the image you've created. One concept that's kind of, I think, worth mentioning when it comes to writing, when you start building your own images by creating your Docker files, is this notion of the build cache. And what this is when you look at your Docker file, the Docker goes through the instructions in the file, and then it reads the instructions, and for each instruction, you're basically creating the layers for your own image. Okay, your image is built up of a set of layers. So what you do is, what the build cache will do is it actually sees if that layer is in cache or not. Is it available in cache? If it is in cache, that's great. It will just reuse that, which is perfect given the network constraints we're working with at the moment. And if it's not, then it will go ahead and build that, which could mean, you know, pulling that image or pulling that layer. And then it'll just save that image layer. So this is a kind of a process which is good to understand when you're actually looking to build your own Docker files, because the first time you maybe create your Docker file and you actually run the build command, it may take some time because it's going to, you know, see if the results are there, but the first time it might, you know, have to do a lot of work to build that image. But then, you know, as you change the Docker file and issue commands towards the end of the file, it'll reuse those steps and reuse the layers that are already there. So the process should be much, much faster the more you do it and the more times you actually run the command. After it completes, it labels all of the layers, and you can actually get a history of what's happened in terms of the build cache. There's a Docker image history command you can run on your image, and that will give you a full history of the makeup of your particular image. And again, just something to think about. You need to, you know, if you use this effectively and efficiently, it means that your build times will be much, much improved. And any changes and you know, modifications you make to the Docker file are typically made to the end of the file and as late as possible in the process so that it's able to reuse everything that's actually in the build cache. So we're going to create a very, very simple Docker file. There's only going to be a couple of commands in it. And like I mentioned, the from command defines the base image that you're going to start with. And then there's different commands that do different things that you'll use. You can, for example, use the run command to execute a command in your new layer, and then it will commit that as a layer to your new image. Command and entry point allow you to define the behavior of your new image. And then copy and add is a way that we can add files, for example, that you need for your application to the image itself. So this is what we're going to do in the exercise. We're going to create a new Docker file. Just remember again, you can use it's all in the text file that's there as well. So it's a simple image we're going to build. So the from command, we're actually going to use this Node as our base image. It's a very, very lightweight, slimmed down version of Node. It's literally got the minimal amount of components or packages there in order to run Node. So we're going to run a very simple web server. So we're going to copy that using the from command as our base image. And then we're going to copy in the actual server.js file. This is just again, this is a, you know, it's a, again, very, very simple Node.js web server. I think there's probably only about 7 or 8 lines of code in here to define the actual web server. So we're going to copy that into our new image using the copy command. And then we're going to expose a port so we can actually make a call to the web server. So we're going to expose port 8080. And then finally, we're going to actually specify the command to run the web server. So we're going to run the server.js web server, and then so we'll create that Docker file, we'll build it, and then we'll run it, and we can go ahead then and test that. So this is taking it now from working with base images to actually starting to look at the process of building our own images, and then we can run those images. So that's great for, again, we're working in single images. The next thing we want to look at is typically for your application, you're going to have multiple containers, right? So you might have a database container, a web server container. You might have application logic running in another container. So containers are supposed to be very, very simple and very easy to stand up in lots of different environments, dev and test, etc. So if we've got multiple of them that we need to configure and define in order for us to configure our own application, well, how do we do that and how do we make that simple? So one of the ways you can do that is using Docker Compose. And Docker Compose is really a tool that we can use for defining a multi-container Docker environment. Okay, so we use this, the way you define it is, again, it's a file, it's a YAML file. It stands for yet another markup language, and we'll use this file to configure the services we want to use within our multi-container environment. And then once you've done that, you can use single commands to start up your entire application, all of the containers associated with that application. You can run tests, you can bring it down, etc. And again, make use of the real power of containers. So nice thing about Compose, again, it works in all environments. Whether you're in production, whether you're staging, testing, etc., you can use this throughout the whole cycle of your development. Okay, so some of the things you can do using Docker Compose commands, similar to the Docker commands, are start, stop, rebuild your services, view the status of your running containers, similar to what we did with the single container. Again, it generates logs, and we can stream those logs and look at the output from the messages coming off the logs. And again, run one-off commands. Run the environment using single commands. Just on the YAML, this is a file that we'll actually create in order to define our compose, in order to create the environment we're looking to make. The biggest piece of advice I can give you in terms of YAML is that it is very, very sensitive to white space. White space matters in the file. So when we were kind of looking at this, the most common thing to have to be sure of is that your indentation is all correct, so don't use tabs. Okay, instead of using tabs, you need to use 2 white spaces instead. So, when you're creating this file, or if you copy paste it again, just be sure that you look at the indentation on it. So this is really the structure of a compose file. And members are listed using this hyphen. It is case sensitive, and it will have a .yaml as the extension. Okay, so the last exercise we're going to do in this section will be to create this Docker Compose file. And what we're going to do is we're going to define our services that make up the application that we want to run. Okay, so this is an example of a Docker Compose file. You can see we're defining the different services here. So we have 2 services defined, or 2 service definitions for Iris and then for a web gateway. This will be similar to the exercise we're going to do later on as well. And then within these 2 services, you define the image associated with the service. So you can see for each one, we have an InterSystems image. We're using the Community Edition for the first image, and then we have our web gateway as the second image, and then the associated parameters with that. So similar to the run command you saw earlier, you can define what ports, if you want to do any volumes or bind mounts, etc. You want to copy files and so on and so on. So you can define in this compose file all of the things you need in order to create your application, and then all the associated parameters and settings you need for that. So the process that you'll go through when you're creating your compose file is define the environment within your Docker file first, so step 1, and then we'll define the services in this Docker Compose YAML file so they can be run together in an isolated environment and making use of all the really nice things that you get through containerized applications. And when you're done, very, very simple, Docker Compose up, Docker Compose down are the commands to bring up your entire application environment. And again, run your tests, do what you have to do, and then you can similarly bring that down. And very, very fast, very, very efficient way to do test, dev, etc. This is just an example you can see where we've created our Docker Compose. We use Docker Compose up. And be sure, by the way, when you do run the Docker Compose, use the detached mode. So the -D at the end means it'll run the background. And then you can bring up your whole working environment and then run some tests or scripts. Maybe you want to do a unit test. And then once you're done, Docker Compose down brings down the entire environment. So it's really, really efficient way to do things like dev and test, etc. within your application. So I think there's one small section, you probably did it already, where we just use the docker logs command to see the information that's written to the standard out, etc. At the end of exercise 4. Exercise 5, we'll use the Docker, we'll create our Docker file and build our image, and then in exercise 6, we'll go ahead and use Docker Compose to stand up 2 instances of, or 2 containers of IRIS. Okay? So hopefully the images are downloading for you guys now, and you'll be able to get to the point where you have the 2 images so we can run through exercise 6. Okay, again, helpers around the room, so raise your hand if you have any questions, and we'll crack on with the exercises. Thank you.
All right, everyone, it's 4:30. So I wanted to talk about exercise 7, which we've labeled as part 2 in our example here. It's really just building a real application. So it pulls together all of the things that we've learned today. We're building a coffee maker shop. Apparently coffee is very popular. So what we're trying to do here is we're trying to pull together everything that we've learned about containers, about creating Docker files, Docker Compose files as well, to build your own, to containerize and Dockerize your application, a real IRIS application, to run that, to upload that container to a container registry, to update your container, upload that change, run it, all that kind of stuff. All the usual life cycle things that you're going to have to be dealing with on a day in and day out basis. So there's all the instructions. They start on page 21. They go on for a little while. I do know that we have some network issues still in some pockets. So if you can't upload the container for whatever reason to the container registry, or if that's taking too long, just cancel it and keep going. It's not going to hurt you anything. I just always thought it'd be great to see your own work up and running on Docker Hub, and you could say, oh yeah, I can go home and I can run that. These are all things you can do back home. These instructions work great. So let me just walk through what this structure is, right? So we're going to build some containers, familiarize yourself with working with the containers, pushing and pulling the container from the registry, and then building a multi-container application with Docker Compose. The example for Docker Compose, we're using running a IRIS web gateway on a separate container from IRIS itself. The reason we picked that as the example is that we are going to start doing that as kind of the default user experience for not shipping the IRIS container, the licensed IRIS container, with a web server in it. We're not going to have that anymore. So you'll need to start doing this for your production environments. There's a bonus section, if that's all done, where you can learn about how to use VS Code with containers. So you could do your development with IRIS running inside of a container. It will simplify your life as a developer. How to connect to it from something like dbeaver, which is a SQL tool. That's all in here. And if you still have time at the end and you want to ask us any questions, or you want to think about how to containerize your own applications, that's what we're here for. We're happy to help. So please have some fun with it. And if you have any questions or concerns, by all means, just raise your hand. Oh, and this is the last section. I forgot about that. So when you're done, thank you all very much. I'm sure that there's going to be surveys. Remember the workshop in your surveys and say nice things if you had a nice time. If there are things we could have done better, please do let us know that we could have done something better. If there's similar workshops that you would like to see next year, I won't seed you with any ideas about maybe a Kubernetes introduction. You guys can come up with whatever ideas you want. Include that in your feedback as well. All right? What, I'm sorry, what? What would the appetite be for an introduction to Kubernetes workshop next year? Anyone? I see 2 people. All right, I'm sorry, I'm the Kubernetes product manager, so I see 112 people. Perfect. All right, thanks.